From this session, we will start one new topic in mathematics, a topic that probably is the most important for any high school, not only in Victoria, but anywhere else. So we are talking about quadratics. Generally we are saying quadratics, but there are too many like small topics involved and we understand under that bigger term quadratics. So this is one part of mathematics that is very common in everyday life, in any other discipline like engineering, science, even accounting, everywhere in everyday life this mathematical process actually involved, and that is why it's so important. Also, almost any other chapter from now on that you will be studying, always you have to use something from quadratics to solve some more complex problems in some other areas. So probably for that reason we will stay a bit longer on this topic, not like any other topic that we did maybe just for 2 or 3 sessions. Probably this topic depends again, but probably it will take us at least 10, maybe more sessions. So it is very important to establish one very solid understanding right at the beginning in the topic, that later on in coming years you shouldn't have any problem. Anyway, we will start, but a little bit back in algebra, because we have to understand a few terms that will help us actually to understand better just a topic. When we are saying mathematical expression, is actually one statement that we can say in words using language, but statement written in mathematical language is one expression. Of course, expression, we can classify expressions on too many different ways, but the most important that we have to understand that mathematical expression consists of terms and factors. Later on we will discuss what terms are and what factors are, but at the moment just to understand that mathematical expression consists from terms and factors. Now we are going to talk from this time about quadratic expression. So why we are saying quadratic expression? What is the meaning of that? And what else expressions that could be? The meaning of quadratic expression is actually that term quadratic telling us that our expression will have one term with the highest power of 2. For example, if we write a mathematical expression, let's say 3x minus 5, this is one mathematical expression, but another expression we can write, let's say 3x squared plus x minus 6, or also we can write 5x cubed plus 2 and things like that. We can write whatever here. What we can see here, the difference between, let's say, consider just those 3 expressions. What we can see here, what is the difference? Okay, 2 terms, 3 terms, 2 terms is not really that difference important, but it is important the power of x, the highest power of x actually in any term. So as here the highest power of x is 1, we are calling that a linear expression. And we did it like solving linear equations, we did linear algebra and things like that. So always our x had power 1, but in this expression the highest power of x is 2, and that's why this expression we are calling quadratic expression. While the other one will be cubic expression, that will come much later. But now we will concentrate just on quadratic expression. So we can write any quadratic expression in a so-called standard form. And that standard form definitely you have to memorize. You have to have that picture in your head, because everything else later on what we will work, we always have to refer to the standard form of quadratic expression. So the standard form of one quadratic expression will be ax squared plus bx and plus c. So what we can see, we have three terms in standard form, and that's why in your textbooks and maybe your teacher or just in normal communication, we are saying quadratic trinomial. Trinomial. Why? Because there are 1, 2, 3 terms. What is important to understand for standard form? It is important to understand the term with power 2, with x power 2, always is first term in that expression. While the term with linear power, with power 1, is second, and a free term is always the last one. Now, how to recognize if one expression, mathematical expression, is in standard form or not? Simply, let's say if we have expression x squared minus 3x plus 1. Is this expression in standard form or not? Yes, it is. Why? Because term with power 2 is first term, like in this formula here. Then term with power 1 is on second place, and finally term with power 0, because don't forget here you can write x to the power 0, which is 1, so we don't need to write it, is the last one. But let's say if we have expression like x squared plus 6 minus 2x. Is this expression in standard form or not? Of course it's not, because those two terms swap their positions. So this one should be here, right, and now we have expression in standard form. What else here we have to understand? We have to understand A, B, and C are coefficients. That is, they are actually numbers, like we can see here, 6, 2, 1 here, numbers that multiplies x. And remember, for quadratic expression, coefficient of x to the power 2 is always a, because later on it will be a few formulas that we will learn, and in those formulas coefficient of x power 2 is always a. Coefficient of power b of x to the power 1 is b, and always this one marked with c. Now, as this expression in its standard form, ax squared plus bx plus c, it's not really suitable for further use, because we can't simplify with other expressions, we can't mix with other expressions. It is quite complex. So we will actually learn how to make this expression simpler. What it means simpler? It means basically how to factorize one quadratic trinomial. Anyway, probably plenty of you knows, many of you knows how to factorize, but I have to warn you on one thing. From my experience, whenever we are doing that topic, students are perfectly fine. They understand everything. They are almost able to do any question. Unfortunately, when we move from that topic to some other topic that involves factorizing, that student should recognize when need to be factorized some expression, then in that case, completely disaster. They are forgetting, they can't get idea, and things like that. So that's why we have to go, even though you may have solid knowledge at the moment, still we have to go to see a bit concepts and to work with those concepts. But what factorizing means? Factorizing means actually one mathematical process that we are changing our expression written in terms to one expression written in factors. So again, what are terms and what are factors? Never forget it. Always keep in mind, terms are parts of mathematical expression that are connected between each other by pluses or minuses, while factors are actually again parts of some mathematical expression, but they multiply each other. So, for example, if you write, I don't know, x squared plus 5x minus 10, then we have one expression written in terms, because we have three terms. But for example, if you write a minus x multiply 3 plus x, then we have one mathematical expression written in forms of factors. We have one factor here and we have one factor here. So factorizing is actually a mathematical process that enables us to change mathematical expression of that sort to bring it in this sort. Now, when we're talking about factorizing quadratic trinomial, we always should keep in our mind what we are doing. So we are changing this form to factors form. Depending of coefficients a, b, and c, we have a few different methods to factorize quadratic trinomial. So, first method will be to take common factor and that method can be used if c equal to 0. So, if c equal to 0, then we will have only those two terms, and then we can take x as a common factor. Be careful here. Also, if c different than 0, let's say one example, if we have 4x squared minus 6x plus 8, still we can take a common factor 2, but what we didn't do much because still in brackets we have one mathematical expression, one quadratic trinomial that we didn't factorize completely. I mean, still power 2, we don't have linear factors. So that's why here we are staying with situation when c equals 0, and there are only those two terms. In that case, we can factorize. For example, if we have, let's say, 3x squared minus 4x to factorize, obviously c is 0, we don't need to write, and we have just those two terms. And now simply taking common factor x, because we have x and x, and will be 3x minus 4. So we changed this expression in terms to one expression in factors, because one factor is x, another factor is 3x minus 4. Don't forget, x squared is actually x multiply x. That's why we have 1x here and another x here from this time. I mean, this is something what you learn very early, even from grade 8 maybe, and we shouldn't spend much time on taking common factors because it's quite obvious. Remember, when we are taking common factor, we are always taking the highest common factor, not just any common factor. For example, if we had expression 4x squared minus 16x, then we shouldn't take just x, because we have 4 as a common factor also, and we are taking 4x, and then of course we have x minus 4 in brackets, and we factorize this expression. Better if we continue with a second method of factorizing quadratic expression, because this is really straightforward and very simple, and definitely here we can't have any problems. So in case if b equals 0, but a and c are opposite in sign, so one minus, another one plus, let's say a is positive, c is negative, or maybe c is positive, a is negative. In that case, we will have actually our expression will be a difference of two terms. And that difference of two terms, as one term is quadratic, the other one always we can make also to be quadratic. We are saying difference of two perfect squares. This is again something what you already studied. So popular between students, I don't know, they are saying DOPS, something like that. Yes, of course, a difference of two perfect squares. And to factorize quadratic trinomial by difference of two perfect squares, we have to strictly follow formula a squared minus b squared is a minus b multiply a plus b. So whenever in our expression b equals 0, but those two numbers, one positive, one negative, to factorize that expression, we have to follow this formula that is easy to memorize. Difference of two perfect squares, yeah, and one square, another square, and minus its difference. Okay, let's see some examples for this. Let's say a very simple example. x squared minus 4. So what we have here? We don't have middle term in quadratic trinomial with x with power 1. So b is 0, that's why we don't need to write here anything. But we have term like c that is 4, actually negative 4, and term with quadratic power is with coefficient 1. Now we can apply this formula to that expression to factorize. Simply we have a squared minus b squared equal, I will write this formula again, and what we have here, we have that x squared is like a squared, but 4 is like b squared. What we have on the other side? On the other side we have just a. So if from a squared we have a, that will be from x squared, obviously, just x. Minus here minus. Now b squared, but here is b. So our b squared is 4. But what would be then b? If b squared 4. I will write b squared equal 4. So b equal what? Of course 2. Because square root of b squared is b. Square root of 4 is 2. And that's why we will make here 2. And of course will be x plus 2. You may think, some of you may think, why I am writing this, because everybody knows that this is x minus 2, x plus 2. I know that everybody knows that, but later on when more complex questions comes, or especially when you have to apply that, you will think, okay, I know what x squared minus 4 is, but I don't know what is this now. Why you don't know? Because you are not following concept. You are not keeping concept in your head, and that's why later on comes to the problem. This is actually concept. This is how to apply this formula on any question, not only on that question. Okay, we will continue. Let's say another example, minus 4x squared plus 9. So again, we have a very similar, almost the same situation, but definitely the same concept we can apply. Coefficient A is negative 4, coefficient C is positive 9, so one coefficient negative, another one is positive. We can talk about difference, and then we can apply this formula. If this minus here sometimes making you a problem, in that case, really, you can change it and to write like this. This is the same thing, of course, minus 4 plus 9, or 9 minus 4 is the same thing, and you can write like this. And now you have exactly situation like in this formula. So obviously, now, again, be careful here with this number. This is first, maybe, point where some students can make mistake. Because if we following this formula, this is a squared minus b squared. So what is b squared? Be careful. We have power 2 here, we have power 2 here. But in our formula, power 2 and everything what is below that power, under that power, is actually b. So here 4 is not under power 2. In this example, power 2 is just for x, not for 4. That's why this you have to write here something when it's to the power 4 to get 4x squared. So what is going to be here? Obviously x must be, because x to the power 2 is x squared. But we have one more number here that we need, so it will be some number here. What number to the power 2 to get 4? Of course is 2. And when you factorize, in that case will be 3, because square root from minus 3, minus, and now 2x, and 3 plus 2x. This is, as I said, could be first point where some of students can make mistake to write here 4 or to write just x, ignoring this and things like that. So keep in mind, in our question, power 2 is just power of x, not power of 4. Okay, we will take a few more examples. I'm just creating examples right now, so there are examples here. It will be different, but what is done actually is better if it's different than to have all the same examples. Yeah. Let's say another example. If we have x squared minus 3 to factorize. So again, we are thinking about that formula. A squared minus b squared equal a minus b multiply a plus b. Okay, a squared, x squared, everything perfectly fine. So a and x minus b squared 3. What? Minus 3 can't be, because 3 is like b squared, but we need just b. Definitely it's not. It will be again something to the power 2 to be 3. Of course, it's not 1, it's not 2, so like here should be some decimal number, but of course we can't guess the decimal number, and we can write its exact value, that is square root 3. Because don't forget, by index law, square root 3 to the power 2 is equal 3, because square root you can write like half to the power 2. 3 half multiplied 2 is 3, half multiplied 2 is 1, is 3. So that's why square root from 3 squared is just 3. And here then will be square root 3 and x plus square root 3. Let's see one more example. To x squared minus 5. Again, if we follow this formula, we shouldn't have a problem. Only keep in mind 2 is not under this power. This power is just for x. So this we can write square root 2 x to the power 2 and minus square root 5 to the power 2, and we have difference of two perfect squares, because square root 5 to the power 2 is 5, square root 2 to the power 2 is 2, and x to the power 2 is x squared, so this is perfectly fine. And just square root x minus square root 5 multiply square root x plus square root 5, and we are just in that formula a, and b, this is like a squared, and this is like b squared. So always keep in mind the formula, see in your expression where is power 2, what is under power 2, and then say what is a, what is b, and go in formula and just substitute. Okay, next one. Let's say x squared equal 25. Here I wrote one equation. Next session we will talk about equations. But if we want to factorize that equation, just to focus a little bit on this from the beginning, we can't factorize like this, so we have to move 25 on the other side to form expression x squared minus 25. Of course it will be equal 0, but we are not really interested in equation, and then we can factorize. That's why at the beginning I said always must be in that form. In my paper here you have probably about 10-15 questions involving difference of two perfect squares, but those questions are not for practicing, because paper for practicing will come later. Those questions are actually all possible situations that you may get. So whatever question you are solving from your textbook or from somewhere else, if you have trouble, simply you can go in this paper and those 10 or so examples, definitely one of those examples will be very, very similar to a question that you are solving. So this is not for practicing, but it's good to study each question to try to understand. Let's see one more example. Let's say 2x minus 3 to the power 2 minus minus 9. Okay. So we have to factorize, and it will be really silly to expand this and then to form one trinomial like this and then to factorize, because here we can very confidently recognize difference of two perfect squares, because we can write 3 to the power 2 and we have power 2 here. I will change it. 3 to the power 2, we have power 2, power 2, power 2, power 2. So we are in our formula, and simply 2x minus 3 minus 3, because this here inside brackets is just a, while 3 is just b, and multiply 2x minus 3 plus 3. Of course, we have to simplify this. 2x minus 3 plus 3 is 0, so 2x, and minus 3 is minus 6, 2x minus 6. Be careful, in some schools, some teachers wouldn't give you a full mark for this question if you leave your answer like this, because still this is not fully factorized. Why? Because there is one common factor more here to take, that is 2, and then it will be 4x x minus 3 result for full marks. Okay, let's see one more simple question just to refresh our memory. Let's say x squared plus 16 to factorize. We have formula, we have this expression. So, bottom right here. Nothing, of course nothing, because we can't factorize this quadratic expression, because this is not difference of two squares, but we are talking about difference of two squares. This is sum, because it's plus here, and both coefficients is coefficient in front of x squared and coefficient c, both of them are positive. It will be exactly the same situation if we had this question. Still, we couldn't factorize because minus minus, by the way, you can take minus common, and you have x squared plus 16, which is exactly the same, so you can't factorize. Keep in mind, we have to have difference to be able to factorize, otherwise we can't factorize the expression. Is there anything else that I need to say about this? Now let me check in this paper if I miss something. No, that's almost everything. Also, only one thing here. Let's say if you have example 2x plus 1 squared minus x minus 3 squared. This is also difference of two perfect squares. So this will be a, this here will be b, and simply we are, because we have power 2, power 2, power 2, power 2, and simply we are just following this formula. 2x plus 1 mine. Here you have to be careful. Anyway, I will do this because just now I saw. So 2x plus 1. Now minus from formula, but b. So b is x minus 3 will be x. And very common mistakes students making, writing minus 3. This is wrong, because we have minus from formula and our b is x minus 3. So we have minus x minus 3, and that is minus x but plus 3. So here must be plus. Take care about that sign. Whenever you have minus in front, like here, then you have to swap signs inside. And of course, when it's plus, then you don't need to do that. So we have 2x plus 1 plus b, so plus x and minus 3, because that is our b. Of course, we have to simplify this. I will do that. Let's see now. Just now it came to my mind to pass you one more question. I'm not sure that that question is in paper. Let's say if we have x power 4 minus 1 to factorize. I mean, it's true. This is not quadratic. Looking like that, that is expression with power of 4. But we can apply knowledge from quadratic to solve it. Because we can change this writing x squared to the power 2 minus 1. And now we have a squared minus b squared. It's quite simple. Then we have x squared minus 1 multiply x squared plus 1. Of course, now we can continue factorizing this. Sorry. Continue factorizing this because here we have difference of two perfect squares, and that is x minus 1 multiply x plus 1. But be careful, this factor we can't factorize because it's not difference, it's sum. So it will be just x squared plus 1. So don't be confused. Whenever it's possible to change those terms to quadratic terms, then do it. This is something like, let's say we can apply this formula for any difference. It shouldn't be power 2. We can have just x minus 2, and still we can apply that formula on this, even though it's not necessary this, but I'm just talking to help you to understand actually concept of this. We can change this. We can write square root x to the power 2 minus square root 2 to the power 2, and of course we have a squared minus b squared, and simply to write square root x minus square root 2 multiply square root x plus square root 2, and we are perfectly fine to raise this in case if sometimes needed. But as I said, at the moment, examples that we did, your questions will be like that. Maybe sometimes something will come up like this for some reason when we simplify the expressions later, but at the moment I concentrate more on those things.